Bom dia, buenos dias, viva momento, доброго ранку. How have you been, guys? Happy to see you. It's been a while, so let's get to code some new cool animations again. In today's stream, we're gonna be doing this one that you could see already in the preview. It's gonna be a disco ball from the Blue Yard, but we're gonna implement it in a different way than the guys implemented it. Because this website is created by the Unseen Studio, which are super professional guys, and all of their websites are just super cool. But anyway, let me know if you can see me, hear me, and let's get started. All of this stuff. Yeah, looks cool and feels cool. Good morning, everyone. Hello to Lviv. All right, so I'm gonna create my boilerplate as usual, and let's see. I'm gonna call this one disco. I'm gonna put my basic template. I'm gonna convert it to the WebGPU. And I'm gonna switch the screen, of course. So this is the website, this is the animation. But let's see. I'm gonna be using the cursor for this one. Okay, already have the cursor open, so I'm gonna do the npm install. Well, because I made it dark, because otherwise it would be too bright behind me. This is the only reason. It is actually quite sunny outside. I just closed the curtains, so it's not always as dark. It is actually too bright. This is the reason. It is dark now. Right, here we go. We have something, but then let's arrange all the windows. Still don't have preset for my cursor. At some point I just switched to it. How do you appearance sidebar? Don't really need sidebar. Let's open this. I also want to open the chat. Chat. Yeah. I learned all of this stuff by reverse engineering the other websites. So you basically can follow my path on the YouTube channel. First streams were not in English, but anyway. Hello to Myanmar. All right. Let me rearrange all this stuff a little bit. Now we get ready to code. Also bigger font. Also, this is gonna be WebGPU. TSL. What else do I need? WebGPU renderer. I also can't use material anymore, so this basic node material, let's say the red one. And I also want to remove this, just removing a bunch of stuff. And this, and this. And this I don't need. All right, it's less than 100 lines of code now. Hello to India. All right, so here we go. We already have something rendering with WebGPU. Was that easier? With three.js, it's quite easy to switch to WebGPU. I just need to put the render async here, just so I don't have the warnings. So where do we get started? We need to implement, let's see, this disco ball, which is pretty cool, but there's a bunch of stuff hidden in here. First of all, there's a compute shader in there. So all of these animations, even though they might look simple to you, but they look quite fluid, you know? You just move the mouse and it's like smoothly comes down to the original positions. And the reason for that, it's not just the one pass vertex distortion. It is a compute shader. We have the state of the animation and we just apply it to the particles or meshes, whatever. The second part is actually the visual of this whole thing. There's a lot of going on actually. There's a fluid sim also on the background. I'm not going to be focusing on that one. I'm just focusing on this disco ball. We're going to be lucky if we can make it in under 1 hour. Because this is, well, trust me, this is one of the top-notch animations, one of the top-notch studios in the world. So even creating something remotely similar under 1 hour is, well, is a challenge for me. But hey, let's go. Let's go with this one. Somehow I can see the last messages here. Okay, maybe this way. Hello to Indonesia. Oh, I spent at least half a year in Indonesia. I wish I could get back there at some point. Yeah, I publish all my code from streams. At least I try to on the Patreon. So this one will be published as well on my Patreon. You can get like a simple subscription there and get all the code from previous streams. All right. Let's get started. First of all, I want to create the compute pipeline here, and then I'm going to create the actual visual. So let's start by creating a compute pipeline. How do you actually do this? With the new three.js TSL syntax, like before you would use a GPU module and stuff like that, but with the new one, I can actually use it right away. So first of all, some random particles. This is what I want. This is the object thing. So sprite node material, let's call this one sprite node material. Let's create some kind of number, which is going to be 100. And let's create the particles positions. It's going to be new, yeah, float array. And let's fill this float array. Of course, the cursor will be helping us a lot with this one. I'm not going to be attaching this one into the geometry right away, even though I can. What I want to create an instanced array right from the start. I don't think I have it here, so it's going to be instanced array. Also would need instance index, I think. There's D here, there's no D there. Okay, seems legit. So usually you would go and attach this one to the geometry and you would just use it as a positions on your sprites. What I want to do, I want this to use as like a storage or like a ping pong buffer in the GPU constructor. So I want like a data texture or something like that, like something to store the actual variables. To do this, I'm going to do const positions, which is going to be instanced array. And then I could put number here, and I think this is gotta be the type of the number that I'm putting in there. So the second variable is just like how many numbers I'm putting there and what is the type of those variables in there. So this way I just created the storage buffer for my positions. Like, not a big deal, it's just the data structure to store stuff. But then I could use this data structure to actually apply these positions for my sprite material. So instead of creating a mesh, I'm going to create a sprite. I'm going to use this material. I don't need geometry for the sprite. This is, well, sprite. So far, nothing changed. Basically, I have enough sprite. It's just I can't rotate now. You can see I'm trying to rotate. I can't rotate because this is now a sprite. And I can also, just to get a glimpse of the new shader system, color node is going to be a fan. I need to run this function right away. And here I can do something like, let's make it yellow. All right, this works. So this is basic shader that I can apply in the TSL. You can't really use React Fiber with the WebGPU yet. So, I mean, technically you can, but I like to have more control over the stuff. And you can't really get this level of control in the React Fiber. I mean, you would get it, but eventually you would just go down to the low level anyway. And React would be just something additional that you're using, not really helping you. React comes great when you need some interactivity, when you need to go from one scene to the other, and it doesn't make sense with these small things like this. Yeah, I think you can. I think you don't need to learn like GLSL now. Even it sounds scary. I mean, it's nice to have it, but you can do everything in three.js now with just TSL, even though it's still developing. But you can do so much stuff there, so you can just use TSL now. All right. That's what I'm trying to show actually today, because I'm trying to recreate that animation. The animation is created with GLSL actually, not TSL. So I'm just kind of following general direction and creating with TSL. Anyway, let's focus on this one. So first I want to create some bunch of particles, and okay. There's also the size, I think you could set with the sprite. I'm not sure if you set it to, okay, particles. And then this particles instance count number. I have 100 of them, and then I also need to set the size. I don't really remember how you do this actually. This particles. I set it to material or to stuff? There was actually a nice example recently by the Mr. Dupe with applying this one, because I don't really need all of this code. I'm just trying for like more educational purposes to follow like the build it up, not building directly the animation that I need, but building something in between as well. All right, so particles instance count number, and then this goes for the material. So this material, okay, sprite node. There's no, okay, maybe here I'll find it. There's not much information actually for the sprite node material, because this is a new one. There's a bunch of attributes that you need to use in order to create some sprites. So let's say, I think it was code pen. Yeah, here you can just basically take how we set it up. Yeah, it's material, and then, yeah, this is a scale node, right? That makes sense. All of these are now into the scale nodes, and the scale node is basically a constant in this case. So we're gonna go, it still tries to tell me that I need to use uniforms, whereas it's not uniforms anymore. Material, scale, node equals, I don't know, 0.1 something. And then alpha coverage, alpha test, I don't know, I need all that. This is what I also need. All right, let's get back to our animation. So now we changed the size of my particle. So far, so good. Now I also need to set the positions now using my instance buffer, instance storage. So this material position node, we can set it directly there. At least we should be able. Didn't work right away. Particle positions. I'm using here number, whereas you could use here both array and the number. If you use the number, it just creates the empty buffer. But if I use the particle position, I think it will create the actual positions. Okay, now it creates one random particle. Well, at least it's better than it was before. Now what I want to do, instance count. Did I miss something here? Instance count. It's just count, I guess. Not instance count, right? Yeah, okay. Because I think, am I hallucinating? No, it was instance count at some point. Anyhow, TSL is a new language, meta language in three.js. It can be compiled both to the GLSL and to the new WSL language, which is used by the WebGPU. And because WebGPU is a big thing coming to all the browsers, basically this is something we are using now. Because it falls back to the WebGL, but it makes sense to learn TSL now, because GLSL is kind of going to the past now at this point. You could learn, like you could just Google three.js, TSL, and for everyone, maybe somebody else also has this question, and just go into the three.js shading language. This is a nice page, and Sunaga is managing this page and did a really good job on documenting stuff. I mean, there's a lot more to put in here because this is all in every three.js release. They are releasing new TSL features now. So development is more focused on this one, and the code is much more cleaner, as I hope I would show you today. All right, so this is how you create stuff. I mean, you could have created these particles a lot easier. I'm using here the particle position in this like weird instance array here. But this is very important because this stuff is, again, just like the data texture. So I could write it, I could read from it, and I could write and read from it in both vertex and fragment shaders. So everywhere. So it's basically universal data structure, which is perfect for creating the animations, compute animations on the GPU, which is what we are trying to build today here. All right, so let's create a simple compute animation here then. How do we do this? So for the, I'll create the function that will be running on the render loop. So for now, all the particles, as you could see, they are having the same position, not really changing position. And I'm gonna, let's change the color because yellow is just gets too much. Okay, the color is here now. Okay, let's have black at least. Let's try to animate them using the compute function. So for this one, I'll create just compute update. Let's call it this way. It's going to be, again, TSL function, which takes no variables. And then in here, I'm going to retrieve this position from this positions array. As weird as it sounds, like this is shader. This is kind of not yet shader, but this one is already a shader code. So with this, theoretically, if I now update this position, I can maybe move my particles. So position, add a sign, something small, X, Y, Z. Okay, maybe X. X makes more sense to me. Nothing really happening yet. This is because I'm not really running this function yet. So to run this, I'll need to do here compute, and here the particle count, which is number from me. And then I'll need to run this animation, this compute function on the every frame, right? This is what I need to do. I guess so. So in here, I'm gonna just run this renderer compute, which is like kind of a weird structure after you coming from the WebGL, because we never had this renderer compute stuff. We had some custom GPU compute stuff, but this is what we need to do. Okay, now we have some errors. Compute called before the, okay. So this means that I'm running render before the backend is actually initialized. Why is that happening? Maybe I'm just gonna be running this one after. Okay, I guess something wrong with an order. My stuff. The compute number is 100. This compute update function at the sign seems right. Should I think it's not get its element, right? Yeah. Why is, I mean, you could see that even the AI is pretty bad yet with the TSL, because it's not that popular. But as basic as this one is might be looking to you, this is actually pretty cool because we just created the GPU animation. And well, this is pretty cool because you would need a lot more code to create this kind of thing to preserve the state of the animation somewhere else. Now let's create a raycaster as well. Let's make it a little bit interactive. Mouse, and then somewhere at the bottom, yeah, something like this. And we could also save some kind of velocity in here. I mean, not sure we will need that for the final animation, but let's just try to do this. Some kind of velocity. Compute update. And in here, I'm just going to use number. Did I broke syntax somewhere? Something I haven't closed yet. Okay, this one. And I need to do the raycaster. Yeah, I'll need to add the fake plane. Doesn't matter. Doesn't matter. And in here, raycast on plane. Okay, intersect objects. This is gotta be an array. This plane. Okay, this is plane GL, and this plane is a mesh. Mesh is added here, and I'm gonna just be console logging the position. Okay, just change the color so it's blue, and I have the intersection position with the raycaster now. So we have some kind of position. Now I want to use the uniform. So const mouse position uniform. And for this one, I need new 3 vector 3 0. And I would just update the mouse position, right? Okay. Mouse position. Let's call this one this. Just trying to create the uniform for the mouse position with a new setup. So Z is always 0 because the plane is positioned like this. The particles are moving out, and I have the position in my 3D space. Now I could use this position to interact with my particles, actually. And how can I do this? In my compute update, I'm going to calculate the distance to my actual mouse position, right? Anyway, const distance is going to be, how do you correctly call this? That's going to be position sub length. And then let's not move particles by default. And then mouse, how would you do this? Factor is going to be something like 0.3 and then 1 minus. Just so we only interact with the closest particles, and then let's multiply this one by something small. Okay, not yet. Okay, we could see some of them moving, but it's just too small for some reason. Maybe bigger. Okay, now it's moving because the particles are probably quite far from the... Okay, and also the mouse position doesn't seem to be updating because... Okay, I can see the problem here. So we have the mouse position. Let's make it this way: const mouse position, and then this mouse position is just this. So we can use both that one and that one, because in the shader I can't. I don't think I can use this mouse position. I have to use the other one. Okay. A little bit confusing now to find the code because shaders are still in here. It's both a good thing and a bad thing. So in here, just mouse position. Yeah. So now I can interact, even though it sounds weird, but probably I would also need to create like the vector or stuff like that, but I don't really care about that. You get an idea that I can interact with these particles and I'm changing the position and everything is happening in the shaders. It's nothing in here. So I could use the physics and stuff. So what I want now, I want to actually try to recreate this scene and animate it with my GPU setup here. Okay, let's do this. I saved the assets from the original website. This includes the cube, which is this disco ball site, the ball, which are the positions, and the environment map. Let's try to use them. So the environment map is actually pretty small image, like just like this, but colorful. Let's import everything. What I need the cube from cube GLB. Come on. Also need the env map from, it's gonna be a JPEG. And now I could also, what's wrong with this one? It's mball, right? How's it? Capital MB. I called it MB. Mcube. And env map is just an env. Okay, so far so good. Now I'm going to switch to the actual 3D models. And how do I do this? Well, let's leverage the AI. So I have the ball, cube, GLB models, and I have envmap as envmap. Help me to load this, all of this using promise all, and only after loading start add objects. Because this is kind of a boring code to load all of this stuff, and let's just try to use the AI here. See how long it takes for the AI to do this. And hello to Taiwan, Vietnam, and all the... Oh, crap. And all the other familiar faces that I see in the chat. Right, let's see what is coming up together. So it created the function which loads assets, and only then it runs all the other stuff, which is correct. And in here it loads with the GLTF loader the ball, the cube. It actually sets the ball model, the cube model, and the env texture, and it also sets this to the scene background. So it's kind of perfect. Saved us a lot of time. Let's accept all of this. And let's see how my scene is looking up now. Okay, so I have the end map here, which we will see soon on some 3D objects. I don't really need this plane, this blue plane, to be visible anymore, so I can just command this one. We still have this simple setup here. Now let's position our objects. So inside add objects, I can actually see now console log this ball model and this cube model. And okay, I'm gonna command this one. I have it working now. So what do we have? Okay, it just does it twice now. So I have the first one is what's the first one? The ball model. The ball model is just the position. So there's points, and each point has some attributes, which are the most important position. The two other I hope we can maybe use later on. But anyway, so the number of particles is going to be this ball model children 0 geometry attributes position counts. And let's see what's that going to be. Would you believe that disco ball actually has 1,500 objects? I mean, I was surprised because look at this one. It doesn't look that big, right? But there's actually 1,500 objects here. Okay, we can see probably only 700, but still, you get the point. So it is actually 1,500 of them. So this is going to be the number that I'm using from now on. Yeah, a lot of particles. Now, as for the cube model, there are two ways we can go about it. We can use the instance mesh, or which I was kind of more inclined to use, I can use the geometry and set some custom attributes in there. So that's what I'm going to be doing right now. I'm going to import my object, and just for a moment, I'm going to add okay, let's remove the particles. So I have the M cube, I have the cube model here. So this scene at this cube model. This is how it looks like, just kind of a brick with rounded corners. Not a big deal. You could see it's not also squarish, whereas the ones we could see is squarish, it will fix that. So, okay, this cube model material equals new 3 mesh physical node material. Let's create a metallic one. Cube model children 0, probably like this. Yeah, now I could see some reflections in here already. So it is reflecting light. I probably shouldn't have removed the add lights. So now I don't think we have enough light here. Oh, maybe I just removed the black. Okay, yeah. So now it looks pretty cool already, right? Like something reflecting something. It's already cool. It's like all those liquid glass demos. Kind of, if people like reflections. And transmissions, or what do we call this? Dispersion and stuff like that. Anyway, now I want to create a bunch of these objects actually and position them on these positions, because okay, let particles positions, it's going to be geometry attributes position array. Do I use already? Okay, cube positions. Now I want to position my cubes all over this thing. For this, how do I do this? So let's geometry. It's gonna be. I'm gonna clone this geometry. Cube model children geometry. I'm also gonna scale this geometry. Scale. What was the scale that I need? Okay, let's at least make it 0.5. Like this. Okay, so now it's small one. I think I also need to rotate it, as far as I remember, both Y and Z. And Z. Okay, so now it kind of closer to what we actually see on the original websites. We have kind of this brick. But this is for now just to test geometry. And because we are mutating the geometry, we could see the results on this already created mesh, which I don't really need in the end. So cube model, material, okay. Let's remove it and let's create a new mesh. The new mesh would be, okay, so let's total points data, this new number of particles, which is basically the same as this number, but anyway, number of particles and number is the same. So this is a number of values that I need to create, and I will be filling this total points data. Yeah, well, basically like this, yeah. And now I could use this total points data for my, instead of particle positions, I could use this one now. So instead of particle positions, I'm going to use total points data. And if I bring back my my old mesh, I could already see something. I could interact even with it. You could see a sphere of these thingies. And now let's, what did I set the size for this one? Okay, let's make it small. So now you could see what was the second object for. It's basically pre-calculated positions which are uniformly distributed. It looks like you could actually procedurally generate them, but I mean, if you know exactly how many you want, you don't really need to do that. Besides this mesh, I think it was like 4 kilobytes or something. It was mbol. How much does it weight? Oh, it's 47 kilobytes actually. But this, it has a lot of additional attributes as well. Useful. All right. Can kind of interact with it, which doesn't look cool yet. Let's get on with it. So now I want to position all of my newly created objects, and for this I'm going to create a new geometry. So let's create a new geometry. Webgl. It's going to be merge buffer. This is what I need as well. And then Gauss number of particles. So on each step, I'll have the index, and I want to save this index into some variable as well. Okay. So let's say it does some stuff here, which I don't. Gauss push current here. Index equals I, not I, divided by 3. Then I'm going to create an array. It's going to be current here, position count, and then index array. I basically want to create a bunch of geometries, but each of them having different attributes. It's going to be, what else? U float 32 array, fill with index. And then I'm going to attach this index to my current gear as an index. Maybe I'll call it FBO index. Right. So each geometry has this now. Do I need to do anything else? Buffer attribute 1 seems to be correct. And then I'll create the merged gear, which is just merging all of this stuff. Do I have any JavaScript errors yet? No errors yet. And then, okay, let's create the merged material and add this one to this scene. So now all of the geometry is kind of in the same position, but I can current gear translate, and we could create a sphere already with this one. So we have positions there. I don't need to create them with this translate function, but we have them. All right. the next step would be to actually position them, but using this instance array. And the reason for that is because if I'm using this instance array, oh yeah, camera down. Yeah, sorry. I don't know why it's happening. Okay, hopefully it is back. Hopefully it is back, so let's continue. I don't know why camera is down actually. Should have been alright. Sometimes the battery plays tricks on the camera. Alright. So what we have here, now I want to use instance position, and I have this FBO index, and the reason I have it is going to be the same index as the instance array. Instance index. So in here, okay, let's remove these particles for now. Yeah, playing tricks with me. Okay, let's command this mouse interaction. Okay, so it's a separate thing because kind of everything in one place. Yeah, matcap should be enough too, but I don't know. I think in the original one they actually used the reflections itself, and that's why I decided I would use them as well. Because it's basically the same thing, either using matcap or sampling the small JPEG texture. In the end, you just sample the small JPEG texture in both cases. So, okay, let's... because I have two materials now, it is kind of messy, because I have this material which I'm setting color, scale, some geometry, which I don't really need. Let's just delete this. So I don't have particles anymore, just have one material here, one compute update, and I have this merged material now. And in this merged material, position node, it's gonna be a fan. And in here, I'm gonna just calculate the okay, plus is gonna be position local, which we are just getting the current position of this one, right? So I could change this one. Okay, do I have position local? Probably not. Oh no, I have it. Then what's the fuss about in the error here? Position local. Yeah, because I haven't returned anything in the position node, that's why. And then const reference index is gonna be my FBO index. Did I call it like this, right? FBO index, right, with a capital I. So I'm getting the index that I set to each of my copies of my geometry. And you know, you can do this with the instance materials, but this way I kind of feel I have more control over what I can animate. It could be different objects, could be not the same objects at all. So, and then I could sample this from my instance array that I have in my compute function. And updated was is gonna be positions element by the reference index. And now I can add my position, add the sign updated pos. Attribute is not defined. Okay, yeah. This part I don't really like, kind of messy to import all of this stuff. So now these positions are coming from the compute shader already, so I can interact with this stuff. Now, the other thing that I want to do here, because they are all rotated in one direction, so I want to rotate them in the similar direction, To do this, I would need some simple lookat function. Yeah, I don't know why. It's kind of, it's as if the battery is going down in the camera or something. Sorry, guys. I guess it will be like that, like every couple of minutes now. No idea why, actually. It show. Anyway, it works, so I'm gonna leave it at that. Alrighty. So now we have this. Now I wanna create a lookat function. So I could actually. And in here, what I'm gonna use is a position and the target. I think it was the same as it was the same thing used in the original one. And up is, so it's gonna be forward target, sub position, normalize. I'm not sure this is the function because I want to return the matrix here. So let's do this like this. Target, sub position, normalize. Right is going to be forward cross local up normalize, and up is going to be right cross forward normalize. And all of this is going to be, I don't need this is going to be right up forward here. The order is kind of important, but I already have this function written before, so this is what I want. So this lookat function would return me the three-dimensional matrix. So now in here, I could do the const rotation. It's gonna be lookat, and then I want to look them at 0, basically. And in here, the updated position. And I think also it's a good way to say that XYZ lookat. What do you mean? I have this function. Okay, at least it's running, and now I have to multiply my position XYZ before I translate it with my rotation matrix. Or maybe it's the other way around, actually. It's just this XYZ is going to be rotation matrix multiplied with pos XYZ. And then we move in it, and it should be mat3 is not defined. Okay. Yeah, I think it's correct now. So they're all looking at the point 0. I kind of want to remove from the compute update. We are getting there. Compute update. Where is it? Kind of want to remove this thing for now so we could just see it. Also, physical material. What do we know about it? Where is it? Physical. In here, site. Double site. Okay. Seems correct. Now, I think I also need to scale the geometry. You could see that it's not scaled correctly. What's the scale? Okay, let's maybe do this. Now they're smaller than they needed. This one should be bigger then. Okay, almost perfect. Kind of good. Yeah, I think this is good enough. We're getting closer to the disco ball thing. Now I want them to also rotate with different speeds. And I think there was also a rin parameter in there, so, which I could use because there was a number, cube position, and merged gear, total points data, and then in here also let rin data, just one, and in here rin data is gonna be its cube positions that I set. And let rin positions is gonna be attribute. What was the attribute there? Rin ID with an underscore. Like that. And this one has a length of, yeah, count exactly as number of objects. So for this rin positions, now we have the rin data. I could also use this rin data as another instanced array, I guess. It's gonna be the rin data array. Okay, why is cube model? It's gotta be ball model. Okay, now seems all right. And we have the rin position, we have the rin data array. And now I can try to use this rin data array inside my compute function. This is where I need to use this. So rin data is going to be, and with this I can basically, for example, add something. I can use this, but in here I'm just going to use the rin data. Okay, maybe rin data multiplied by something small. And you could see that the rin data basically says how high is the object is on my whole sphere. So what I want to do now, I want to rotate each of these points around each axis, not each axis, around y-axis. So I have this point position, and with time, basically on every step, I want to rotate this one. And then there will be only one step left to create an actual nice disco ball thing here. So distance factor, rin factor. Okay. Compute update is what I need to update now. Okay, a lot of stuff we're doing today, actually. Quite a lot of it. Compute update. Ooh, so. And which I want to be rotating? Just the position. Okay. Create. Let's see how good the AI is with this one. Actually, pretty good. Should ask it more often. So actually, I think it pretty much did already what I need to do, except the angle could be just something really small, because this one will be a run in the request animation frame loop, so it should be something is wrong. Function call expected. Okay, maybe. So it's here. So it's probably a sign. Position XYZ. Assign rotation matrix. Maybe Maybe just like this, the other way around. Okay, what is wrong here? Rotation matrix, cosinus, sine. Can I actually do this? I think I should do the negate here stuff. Oh, that was the reason. Okay, just didn't know that I can't use the minus here. All right. All right. Well, you live and you learn. And then, okay, this one multiplied by the, let's create a random, let random speed equals hash print data. And then add the random speed in here. Hash is not defined. All right. All right, hash is not defined. I can write my hash. I'm old enough. So it's gonna be print data multiplied with something. Add 1 divided by 0.5. Ah, yeah. I keep forgetting. Okay, now everything is rotating at the same speed. Small stuff left to do. So the rin data should be. Why is it everything is in the same? I can just do position Y here. Okay, now it's different speeds. All right. It's something, I guess. But add 1 divided by 2. So basically was trying to just randomly rotate them, but for some reason it's not that random when you need it. When you don't need it, it's pretty random. Okay, rin data. Random speed, sine. Okay, maybe. Maybe this one. Floor in data multiplied. Okay, now this looks random. Maybe I just picked some numbers which were not really that random. And then I could also create kind of so everything rotates smoothly, at least a little bit, but some of them are faster. Okay, this looks more pleasant now. Getting there. So two things left to do here. First, nicer, more random colors, more discrete colors on each of them to make it more discoverable. And the second one is to bring back the interaction part, which are both not that complicated, but then it's something to do. All right, so let's get back to the my material. Compute update. Okay, maybe let's first make interaction and then make the nice colors. Let's do it this way then. So I have already the distance factor in here, and let's just compare the XY here, and because just comparing where I'm pointing my mouse, kind of like a screen space, not quite the screen space, but kind of like a screen space. And then I want to have the original position, which is going to be basically position to var and normalize, because this is all unit 1 sphere. Normalize. I share all the resources in my Twitter actually, so just follow. I'm just constantly sharing tips and tricks on the three.js and stuff like that. So I have the original position. Now I have the distance. I have the stuff, maybe, I don't know, 0.5 at least. Distance factor. And now what I want to change kind of the radius of the objects when they are close to my mouse. So I'm going to create the target, which is going to be radius 1. And if target is, if the mouse is closer to the target should be bigger. So target equals, okay, minimum float 1.2, so it doesn't go all the way. And in here, I have this value which comes from 0 to 1, the distance factor. So let's make it like float 1, add distance factor multiplied by something small. Okay. And then I could just multiply my position. So position mul assign target. Okay, minimum is not imported. The hell with it. Okay, something is happening. They're not quite returning to the original positions, but we get the interaction now, which looks actually pretty cool. The animation itself, kind of like a nice background animation. Anyway, so now I want to get back to them. So once the mouse is out, I want it to return to my position. So target and target. So I want it to animate, I want to use kind of a lerp function between these two. And what I'm going to do here is I'm going to assign position assign. And in here, I'm going to be mixing between two positions, the original and the other one, depending on how far the mouth is. And it's going to be like a lerp function. Okay, if it's lerp function, putting on the last one what I need. First one is going to be position, and second one's got to be the target position. So it's going to be original position to var multiplied with target. This is where it should be, target. Mix is not defined. The hell with it. Okay. See, we're getting there. And because it's not direct vertex animation, it's much more cooler this way because it's so smooth. And if I set the variable actually to something, what Yuri just said. Let's say the maximum is much bigger. Okay, looks pretty cool. I think there's also a sign stuff in there added. So the distance modifier, distance factor, which is multiplied by 0.2, I could multiply it with the sine function. And the sine const sine addition is going to be what? It's going to be sine and then random speed. Okay, it's just another random number. Random is going to be hash instance index, let's say. And then Is it working actually? Random number. And then in here, sign random number multiplied with the something 2 pi. 7 is closest to pi as I can generate right now. And we have to add the time in here. I don't have time yet. And then I also need to normalize this between 0 and 1, which means adding 1 and dividing by 2. Looks complicated, but it is actually not that complicated. Okay, sign addition. And let's also implement the time uniform, because I don't have time. Const time. This time. Okay, now we have time. And now it's kind of more random, and it looks much more pleasant and much more similar to the original animation. So if I now bring it back, much cooler than before, right? And that's just because some of them are like following their sine curves, which makes it so much cooler and more pleasant to interact with. Well, I guess you could increase this coefficient to make it more react more faster. And I think also there's some addition to the whole thing that randomizes them. So original position. So this one when it's close to mouse, and this one I can like always add something to this one. Sign addition small, something like that, I guess. Should I add it to target? I guess I should add this one to the target. I just wanted to kind of randomize them a little bit so they are like moving between one another. Just give me a couple of minutes, guys, and I will read the chat and answer all the questions. There's one small thing left to do. I think it's good enough. I'm just trying to be too picky on this one. So it's... maybe just here. I just wanted to add supple animation in here. Another one. How do I make it? How do I make it again? An addition small. But this target is only when the mouse interacts. Right. So I could add it to the target, maybe make it bigger. An addition small. Not yet there. Target, okay, I'm just probably down there because I'm resetting the target in there. Okay, somehow it doesn't seem to work. Multiply it with 100 should be a big thing here. Yeah, also pretty cool, right? So it is a big thing. So target and a sign maybe like this. Yeah, all right. This is it. Which is also pretty cool, if you ask me. And then... yeah, and then smaller, which is also a cool one. Like all of them are looking pretty cool. Okay, now a little bit randomness added, and you could see it actually adds to this whole thing. Like they are subtly moving between one another, and when we hover the mouse, we just distort them, which is looking pretty cool. All right, the last thing that we need to add is to actually like randomize the colors. There are a bunch of ways to do that. Like the guys mentioned, we could use matcaps, we could use, we already have the environment map texture here, so I could use that one. And okay, have my material, which is merged material, color node. Okay, I have the reference index, I have the updated position, I have a lot of stuff. Now what I want here, I could already use my look at point thing and create my rotation normal. So first of all, have the updated pass, local normal. Right, no errors so far, but the colors are changing because we are returning color, which is actually updated pos, which is some kind of animation, not correct one, not physical one, but still. Now, what else I can do here? We need to get this rotation matrix again. So rotation matrix is going to be updated post looking at the 0. Rotated normal is going to be local normal multiplied with this one. And I also have to normalize this one. Maybe it's the other way around. Okay. So the normals seem to be correct, I guess, right? Kind of, it's the color tint that you see now, those are the normals. And now, my idea was, like, I don't really remember how they did this, but my idea was to quantize the normals. So for this file, I will do the steps float, let's say 100. I'm still putting those dots in there, even though I don't need to. And what else? Quantized normal is going to be what? It's going to be the rotated normal multiplied by steps, then we round it, and then we divide it by steps, and then we normalize it again. That way, the normals would not be like slowly moving, they will be just moving in steps. And that will get kind of a disco ball animation, I hope. Just didn't work out yet. Oh, you could see actually. They are like changing the color more like faster than they changed it before. And that probably would be better with the environment map even. So let's, okay, I want to sample this scene background, create UV for spherical ports. Okay, UV is going to be A10, ACOS, and then I could use the texture sample and then return. Okay, maybe it just works. A10 too, all right. And ACOS. Yeah, see? So obviously you'll need to tweak this thing a little more because right now, like they're blinking, you get the feeling already of the disco ball thing, but it's maybe they use the different way, right? But or maybe I don't know, maybe I'm too picky for myself actually. Maybe it's good. I don't know. What do you think, guys? It looks like a disco ball to me, but you could obviously play a lot more with this texture with where do I have the icons? Like, I don't need to remember this anymore, right? You could just ask the AI to put those UVs if you know what you actually need. Like, because I knew that you could somehow create the spherical coordinates out of this normal thing and then just sample the texture, which we did here, basically. This is a texture, and this is a sample, and this is the UV to the spherical coordinates. Well, I guess this is it for today, because the rest is a lot of tone mapping and post-processing to create, because the colors are different here. There's also bloom applied here, and the fluid animation. There's a lot of stuff here. You can see how it's blooming in here. A lot of things in here. But in principle, this is the idea. By the way, let's just see what's going to change if we create some tone mapping. I'm just going to ask. Okay, this is the cool tone mapping. This is official now. I mean, maybe. There's also obviously the anti-aliasing is hurting my eye. Yes, much better. And also because it's metallic, metalness, we could still see the reflections. If I like maybe roughness a little more, there's no obvious reflections now, but the colors are changing. Pretty cool, eh? So I guess this is it. We gotta finish at something, and the result looks pretty cool to me. This ball is pretty cool, the interactions are cool, and we're using the GPU animation and all under 1 hour. And this is kind of, I mean, might look like we just wrote a lot of code, but this is actually a lot of things which were a lot harder to achieve before. Because again, we just did this with this compute update function. This thing is heavy lifting all the animation of these 1,500 objects. I mean, we could probably have a million of them there, right? Easily. And they would be still animating there. Because we're not really animating geometries or stuff like that. We're just animating the points in space. This animation is basically run on points in space, not on these 3D objects. And 3D objects are just reading the positions then, and we're taking the rendering then. So the rendering would be a more bottleneck with this animation than actually the computing of those positions. Whew, it's been some ride. I hope you guys like this one. Comment something, write me the other websites that you would like to see. And I'm gonna read the chat a little bit, and if you have some questions, you can ask me right now, but I'm gonna be finishing the stream on this one. So any chance you cross-post your tips and tricks to Blue Sky too? Oh, I have to actually, because I don't really like all this Twitter and Musk thing. I kind of hate it. But then it's like you just adding another layer of you posting somewhere. Well, thanks for actually mentioning that, because this is the thing that I keep forgetting, and if someone asks, I will then do this. Thank you, old Sigochia. Yeah, he can take your job. Well, I mean, it's getting better every day. As you could see, it's generating some 3D matrices for us. It's doing a lot of stuff in here. Some spherical UVs. Like, how many of you can write those UVs from the memory, right? It's kind of, you have to do some mental effort for that. Is it a good thing to create multiple scenes for net orbit controls in 2 different sections? I mean, it is possible, but then React Refiber actually is leveraging the scissor, I think, or the way that you can cut parts of the canvas and do this. So React Free Dry is actually doing that. They have, I don't know how they call it, either portals or something else, or just port, or just HTML. I mean, you could just put some parts of the canvas. So I would look in that direction. But in, like, I don't know, 70% of the cases, it's better to have a full screen canvas and control it yourself than all the rest. Any news about three.js today? Well, here are the news. We just created Disco Ball, and the compute function is awesome in new three.js TSL. So WebGPU is actually awesome, and I hope you will be using it, because the guys in three.js are doing a lot of effort from the developer experience perspective to make it more usable. Even though I made some errors, we actually did a lot of stuff today. Is there any way to make cursor more familiar with three.js creative dev stuff? You can just basically copy paste any demo, and I think this is the recommended approach. So once you want to achieve something, you just put either docs straight into the chat or just the demo. It's kind of similar demo, and this is how it learns from you. And then you could also have this cursor rules thing where you could add all the stuff that it's learned. I don't use it yet, but I have to, I guess. Thank you guys. Yeah, I cannot do that today. Share some resources to learn TSL. I mean, the main resource would be trial and error, but then the three.js shading language page on the GitHub repository of three.js is the best way to start it. And then just go and ask the community. Everybody is being so nice about TSL, and you can even chat with the creators of TSL themselves. Thanks for not using P word today. Igloo, maybe we could do Igloo, because they have the actually pretty cool compute animation in the footer where the particles are forming a 3D shape. So maybe we do that. Yeah, hopefully WebGPU will be soon universally supported, but then it falls back to the WebGL and the three.js, so you could already use it. And hello guys to all of the countries. Hope I didn't miss any other questions. WebGPU coming to Safari. Yeah, obviously WebGPU is the future and WebGL is the past. Although WebGL is universally supported, so yeah, you have to take what you can take, depending on your projects. three.js will in the future fully support. Of course it will. This is the goal. They at some point, I guess, they will be just WebGPU, and WebGL will be something like in the fall, something as a fallback. And at some point, I assume they will be just deleting the parts related to the WebGL, because there's a lot of shaders, a lot of chaos in there, and although it's important, it wouldn't be used in the future anyway. So guys, I hope I answered all of this stuff that you asked. The cursor tips. I mean, there's so much information right now about the cursor, and from the bloggers, from the developers. I guess the main tip would be, if you want to create something complicated, you would create a list of tasks and follow it, those steps. And then the other tip, I think the most important cursor tip that I can do for you, is that if you want to create something with the cursor, it is so much better if you actually know how to do that without cursor, because then you would just fast forward all the boring tasks and just tell it to do it in steps that you would take, and you would be able to check every single of those steps because you already took them in the past. So it's for my main advice is to at least once to create something without cursor, and then go and create a lot of stuff with the cursor again. Maybe some unfamiliar stuff even, but still, if you know the general structure, it makes it so much easier. Yeah, I think this is the goal for the three.js. They will try to support everything, just as they tried with the WebGL to support all the features in there. It basically depends on the community and the people working on there. So if you like the three.js, you can join and maybe implement some features from the WebGPU. Like the thing that we used today was actually also like strictly WebGPU feature with the storage buffer, which is hidden behind this simple instanced array, which is a wrapper for the instanced storage buffer, blah blah something. It's a complicated word, but all of this together. I mean, this is just a wrapper, which is useful because, as you could see, we could use it in every shader, just sampling by the index. It's just so stupidly simple, because in the WebGL you would need to sample texture and know which element from the texture is which, but here is just an index. So as you could see, I created a number of similar geometries, but those could have been different objects completely. And I could control anything with this just by setting this index, which connects both worlds. So I hope you guys liked that one. Again, comment, share. Hopefully this was useful to you. And I'll be streaming in future again. hopefully very soon, like next week or in 2 weeks maximum. So stay tuned and follow me on Twitter because I'll be sharing some more tricks on Twitter again. Guys, stay safe. And again, the most important thing that I could tell you, if you love someone, just tell them that you love them. Being your parents, your children, your siblings, your significant ones, anyone. Just don't forget, because life is fleeting. You have to tell people that you love them. Right, yeah, it's all more convenient. So guys, have a great week and see you soon. Thank you for being here.